In this video lecture, we will discuss Python pitfalls. What do I mean by that? We have certain expectation of array behavior or program variable behavior in Python based on our understanding of C. Okay, so we know how C functions behave. So or C arrays behave. So we think something similar. But Python arrays and Python variables behave somewhat differently. Okay, and let's look at an example. Okay, so this is what is this lecture about, and especially for Python codes with arrays and large codes, we need to be careful. We need to know the subtleties. Okay, so here is a small snippet of a code. So we have an array X. So let's just use this one. We have an array X, which is 1, 2, 3, right? You can see from the arrow, NumPy array, and I print its ID and X, variable X and ID. So what is this? So the array is 1, 2, 3, and its ID is this big integer. It's a memory location. ID is where it is. Where is it located? The first entry of array. So it is 135021955596. Great, no problem. But now I want to do an operation x squared. In Python, what is x squared? It is element by element squaring. So what do I expect? The numbers will be 149. Expect, no problem. But the question is, where is x after this operation? So in C language, if I do some operation on an array, well, in C we need to do a loop, right, for C arrays, but in Fortran we'll do object-oriented. Well, we can do one line, but in C, unless you do vectors, it is a loop. But irrespective, we expect X to be the same old array, right? I do an operation, I multiply by 2. The array is not supposed to change. I just do element by element multiplication. It turns out, you can see from here, the address of x squared, the new array X, which contains x squared, is different. So what has happened here is that we had an array X, but when I did x squared, so there was a new array which was created, okay, which is not expected. I mean, I did not expect it, but that's what we are getting in this example. So this is in fact not a good news. Suppose I'm working with large arrays. Okay, my array size could be 1 million, and I do a certain operation. In fact, this will work also when I do x equal to 2 star x. If I do this simple thing, multiply by 2 or multiply by 1.5, we are going to get a new array. Now this is not good, right? Because we are going to create a new array which is large. First, loss of memory. I mean, we are wastage of memory. And second thing is, I was not expecting it. I have in my head that, well, I'm working with the same array. So this is what we need to be careful. There are ways to avoid it. Avoid this wastage. Okay, so I'm going to show you in the next slide how to avoid this wastage. So this, you can see this part of the function. So the upper part is same as before. This one, we create an array X, but I want to square it. So what does square mean? I just multiply by x itself, no? So this is that object star equal to, so x star equal to x, it will create, x will become x squared. Now this time you can look at the IDs. The ID in the right hand side, this one, is same as previous ID, right? 56. So when I did this operation, this operation, my array remains the same. So this is how I should square an array. Okay, now I'm not creating a new array. Similarly, if I was multiplying by 2, so you should not write x equal to 2 star x. This is not to be done. What we should do? We should say x equal to x star equal to 2. So if we do this, then we are safe. Right? Now the next one, I mean, just this is a repetition. If I do x equal to x star star 2, it is squaring the array. If I do that, then I'm creating a new object, a new array. Okay. So well, Python has its own ways of doing things, which is not same as C or Fortran, and that's what is a way out. Now let's see why, the reason for it. I mean, why is it behaving that way? There is a logical reason for it, and that's what we'll discuss in this presentation. So Python variables are reference type variables. Okay, what does reference type variable means? Because you may recall that Python, every variable or every function variables, they are all objects. Okay, objects. Now, so what's an object? So in fact, we need to be careful. So let me just write it here in this location. In C, we write x equal to 5. So I have a slide in next, but I'm just explaining it here. So here, x is a location where 5 is stored. X is basically pointing to location where this variable 5 is stored, x. So x is same as 5 in C. This is in C. In Python is different. Python is very different. This 5 is an object whose value is 5. So we need to know where it is, what data type. So object has many other attributes or other information about the variable. Okay, so since it is an object, it is called reference type variable. Okay, so in fact in the next slide we'll see that. So objects of C++ are reference type variables. C++ objects. However, if you have C++ variable like integer, so when you create an object using class, right, we did that before. So if I use an object using class, then it's a reference type. However, if I use integer, so this is in fact, we have to be careful. So this is integer, int. With integer, then it's a value type variable. Okay, so Python variables are objects, so it is called reference type variable. Okay, on the contrary, the integer and float variables of C are value type. So you see this word value type. So they are different type, and that's a key thing. So that's why these two variables behave very differently. So let's look at this C type variable. We got, so we need to see this a bit carefully. So we have created a variable. Let me just use some other slightly darker. It is. So we have integer x. Okay. Now in C, what happens? So we have variable x, which has storing integer 10. Okay, so x is same as 10. Okay, x is in fact is a variable id or variable name which is same as 10. Now if you may recall, the c also has a pointer, so c pointer here. So pointer is, if I write p equal to ampersand x, so what does it mean? P is the address of x. Then this p is a pointer, and so this address, where is it stored? Where is x stored? X is stored here. So this pointer p, these numbers are, to me it looks pretty small, 4473 or whatever, 856. The last three digits are 856. So the address where x is stored is a pointer. Python is something like address, but it's not quite. So in some sense, you can think of, we have Python object, which is 5. So the value of the there is a field which takes the value 5, but when I say x is pointing to 5. So x is something like p. So this for Python. Okay, so that's a key difference. So if x is equal to, I should have used x is equal to 10 in C. So x and 10 are they're same. However, in Python, object, which is the sacred thing, object 5, okay, which has other stuff in it. In fact, in C, this number 5, this number 10, sorry, the C number 10 requires how many bytes? It requires 4 bytes. 4 bytes. But in Python, to store this variable 5, it's an object, so it has more than just 4 bytes. I think it's around 28 bytes or so, because it has other information, what type of variable is it, and so on. So every number or everything which you are using in Python is an object. So it's bulky because each object keeps a number as well as other attributes like data type, location, and so on. Okay, so it takes more space, more memory. So let's look at a slightly detailed thing of reference type variable. In Python, as I said, things are reference type. So we have, so I'm going to look at C++ object. So this is an example of C++ object, this one. So class student, okay, and it has two variables. Student has two variables. One of them is name, another one is roll number. Okay, so student, when I declare a class or define a class, it is not same as name, student name. A student has other attributes, roll number, it could also be graduating year, it's a grade point average. So there are many attributes to student. In fact, they are all of different data types. Okay, so let's look at how do I create this thing. So this is a class declaration in the left. Now in the right we have create an object. So student S. So we create a student S whose name is Alice and whose roll number is 1. Okay, so this is called instantiation of a class, which we discussed some time back. So we have instantiation of a class and its roll number is 1. So we have one student. If you have another student, then we call it S2, and the S2.name and S2.roll number will be their attributes. Now we can look at where is this object stored. So address of S using ampersand operator, this operator. So you see ampersand S is here. So when I print it, I get here this address. So this address is address of the class S, student S. Okay, and near this address well, I mean, we'll have various memory locations. Some will contain the name, some will contain the roll number. Okay, so this is how this is more than a name. Okay, object is more than a name. You can also get the address of the object by another function called address of s. Address of s. Okay, so you can get in two ways, using ampersand operator or address of s. Okay, so I hope you get an idea that s is more than name of a student or roll number of a student. So in Python, when we say x equal to 5, so this 5 is an object. So this object is not only number 5, but it has other attributes, and that's why x is pointing to this object 5. Okay, and this 5 is, I said, like data type is stored along with 5. So in Python, we don't worry about declaring a variable because it is stored. Its type is stored. The interpreter knows what kind of, by just seeing the number, what it is, and it does your work. Okay, your life is simple when you write the code, but in the background, Python is doing work, in the sense what kind of operations are allowed for integer or a string. Okay, so that's the deep difference. So integer in C is value type, but integer in Python is a reference type. Okay, so Python variables are objects, as I said. So we have this object print. So this is x equal to 5. So what is sacred is 5. Okay, so we're going to see that in some more examples. X is 5. So when I say type of x, so type of x, so I'm going to print it. So it's a type of x equal to, this is a class and its type is int. So you see this 5 is a object. Similarly, when you have string hello, then type of y is str, string. Okay, so a picture, illustration. So we have this variable, this object 10. Okay, this object 10, and so what is x? X is not 10. X is referring to the location where this 10 is stored, and location stores 10 as well as other things which I am not writing it here just to save stuff. So there are other stuff like data type and so on. Okay, so x stores the address of object 10. So now in Python we did discuss it some time back, what is called immutable object and mutable objects. So let's, since we are doing this discussion, let's recap. Okay, it's a very important concept. So our integer data type, Python data type, integer, float, complex, string, tuples, they are all immutable, sorry. So when I have integer 5, so this integer cannot change. So this integer will, once it is created, it will be there in the memory and it cannot change. Immutable. Mutable means which can change, and immutable means which cannot change. So once I create an object 5, it will remain there until I clear this program or I stop the program. Stop means I exit the program. So everything is lost. All the objects are lost. Same thing with float, complex, string, tuple. But you see, something missing is arrays or list. List and arrays are mutable. They can change. Okay, so we will illustrate by an example in the next slide. So value of immutable object is unchangeable once it is created. This 5 cannot change. So this is what we got here. So x equal to 5, x is 5 here, and print id of x. So this is the id of x. Okay, and this is the object 5. But when I say x equal to x star star 2 means square it, then what has happened to its id? So x has become 25, and its id is different. You see, it's like 4540 da da da, which is different than this. You see, this would not happen. C would have this variable x would have been 5, and if I say x squared, okay, I'm just not writing star 2, so it would be pointing to the same location. The x location does not change because it is value type variable. Here this object 5 is sacred. This 5 is sacred, and x is, so this 5, x is pointing to this 5. But when I say x squared, this object 5 cannot change. This cannot change. So we create a new number called 25, new object called 25. Now x points to this. So you see, this was one location for 5, and this is a new location. So now x is pointing to a new location, this new location. That's the difference. So we create two objects. It's not that in C this 5 was replaced by 25. So we have location where 5 was there. Then we replace it by, this is rewritten. So we remove this and write 25. But not in Python. Python it is, we create new object. So in fact that's a subtle part, and which is not discussed in usual discussion or textbook. But you see that for arrays we had to be careful. It turns out with integer it doesn't quite matter. I mean, my new value is 25 and I'm basically dealing with 25. So you see my x was 25 in C. Here it is not, I mean, x address has changed, but my value is 25. So with integer, most of the time it doesn't cause catastrophe. But with arrays it can cause catastrophe, especially with large arrays. Okay, so we have this stuff right now. So let's look at some more example. Okay, so x is 10. Okay, so 10 is stored here. You see 10 is stored here. Now it has an address. So x is pointing to 10. Okay, so x will be basically this address. Now I say y equal to x. What does y equal to x means? So y will point to the same object 10. Okay. Now can you see the difference between C and Python? In C, if I said this, y equal to x, y will be new. So x would point to this integer 10. So x is basically 10. And you say y equal to x, that means y will be new memory, and where 10 will be there in C. This is in C. But in Python, y is pointing to the same location. Okay, so y and x are two different names. You can think of alias, because it's pointing to the same object. Object is sacred. The 10 is sacred, not the names. Names, okay, we have two names for the object 10. ID of 10. What do we get ID of 10? It is this number. So this number is coming as ID of 10, this number. ID of x. What is ID of x? Same, you know. So x is pointing to 10, so it will give you that address. This address is coming here, this address, which is same as here. ID of y. Oh, well, no, but I'm coming to ID of y later. So we create a new, well, ID 11. But it says, well, 11 is not there. So it creates a new object called 11, integer 11. And what is ID? Is address is stored in 4473 So this is that address. Okay, they're not consecutive. Well, maybe they are 24 and 28. That makes it 50. 30. Okay, so this is difference of 32. So there could be something else in between. Anyway, so this is a new location where this number 11 is stored. Get size of 10, and that is 28. By the way, sorry, I should say that this is hex representation. Okay, so in hex representation, the difference will be probably 28. So this is a new number. So we need to see the difference. I can't simply do subtraction. So 5, 6, this is 2, 32. 32 is 3 times 8 is 24 plus 2. Yes, in fact, 3 times 8 is 24 plus 2, 26. Okay, so it is okay. Anyway, so this is a new location. Okay, for 11. So each object is taking 28 bytes. This is bytes. Okay, so you should know this, that this is bytes. Integer in C would take 4 bytes, unless the long integer takes 8 bytes. So objects take more space. Okay. Now this is a slightly more complex example. So let's look at the state. So x equal to 10. So this is this 10 here. Then we got y equal to x. There's y equal to x here. Then ID of y. What is the ID of y? It is same as ID of x. So this is ID, same as before. And here x is 100. So we create a new. So what has happened? So this is another surprising thing. If you are thinking of C, so what is happening here? So this 10 is a earlier object. 11 already was there. Okay, so in fact I use the same Python screen. So 11 is not lost. 11 is there already. Now I create a new object called 100. This is a new object 100. Okay. So it is in C. What would happen? C would have been x is 10. When I say x equal to 100, so this is replaced by 100. Right? But not in Python. Python creates a new number called 100. So a new location, this object 100 is created, and it has a new address. This address. Okay, this address. And ID of x is this. So you see, now x is not pointing to the earlier object, is pointing to the new object. There's a difference. Okay, so what is sacred is this objects 10, 100. These are integers. X is merely a label. ID of 100 is same as ID of x, right? Where they point the same object, and ID of y. So earlier x and y were pointing to the same object, but what happens to ID of y? Will y change to the new address? No, y is pointing still to the old object. This is 824. This is 824 here. Okay, so objects 10 and 100 remain unchanged. That's why it's called immutable variables. Integer, float, string, and tuples. Tuples is like a list, but it is immutable. That's the main difference. List is mutable, but string is tuple is immutable. Okay, so let's look at mutable objects. So what is a mutable object? List and arrays, they are mutable. So let's look at the list. So I'm going to go step by step. we create a list 1, 2, 3 whose label is A. Okay, so this is our list 1, 2, 3 and its label is A, and it has an address. So if I say ID of A, before that B is also pointing to A. So B and A are same, pointing to the same object. This again would be different than C. If I say B equal to A, that means B would have been a new, would have copied. B would have gotten a copy. But here it is not copy. So B and A. So this is what happens. If in fact I'm used to C. I used to basically work with C. So when I say B equal to A, you think that you created a new array B. But no, it is not a new array. It is it's pointing to the same array. And okay, so that's a catch. You have to be careful. Print ID of A and ID of B. They are same ID, 512, 512. It's a big number, so you don't need to look at in with microscope. Just look at some 4 digits, 0512. I remove one, so it is 1, 2, 3. So pop is remove an element. So I remove an element 1. So what is A after that? So sorry, pop 1 is not the first element. 1 is second element. 0, 1, 2. So that's index. So 2 is removed. 2 is removed. So what remains of A? Print A and B is 1, 3, and B also 1, 3. So what has happened? So when I removed it, it is the same object which has been removed. Okay, so that's why I call it mutable. A can change, and since B points to same object, B can also change. B and A are same. Okay, no difference. So it has become 1, 3, right? So it is 1, 2, 3. So remove 2. So it is 1, 3. And ID of A and B. What is ID of A and B? Look at it now. It is same as before. 0512. 0512. So after pop, we have changed the object. I see something has been removed, or I could have added something. So this object, you can change it. That's why it's called mutable. So which is same as C. No problem. We can add. But in a list you can add. In a dynamic arrays of C you can add an element. But when you say B equal to A, this is different. Okay, so this in C would have created a new array, but not in Python. Python it will be the same array. So some more example. So what if I do C is A colon? So what does it do? It turns out if I do this, then I create a new array, which is a copy. So we look at ID. So C is same as 1, 1, 3, right? C is 1, 3, but its ID of A was 0512, which is here, but ID of C is different. So this is for copy. So what I'm doing here is this copy. So if I had done C equal to A, it would not make a copy. C and A will point to the same object. However, you say C equal A colon, then it will create a new object. In fact, we need some of it in our numerical computing. There's some other ways to make a copy, which we'll do it later. So difference between Python and C, I have explained here. So basically this notation that when it is C equal to A, in Python it would be pointing to the same object, because objects are primary, but in C is a value type. The arrays are also value type, and it will create new arrays. So ID of X. So this we did it before. So X square, this is a new object. So new object means X is pointing to different location, new object. How to fix it? As I said, we can use this star equal to this operator, star equal to. So instead of saying x equal to x star x, you say star equal to. So this is a convention. Python follows this convention. So this is the convention. And so print x idx, and you see that the ID is not changing, 3552 3552, but now x, the value of x has changed. It's mutable, so its value has changed. Whether this would not be possible for integer x. Integer x, you try this, you will get new object. Okay, so integer it doesn't work, but for mutable objects like list or numpy array, it works. I must make one remark. Not going back. So I used this. It should have been np.array. Okay, np.array in standard Colab, but I was using IPython where np is already imported in IPython minus pylab. Okay, so that was the old notes. So just to say that, so if I use IPython minus pylab in the terminal, if you do this, then it will import NumPy and matplotlib. Anyway, so these are some more examples. So this is for squaring it. We did this before. So it's coming here. So here the ID has changed. This ID is changed. Sorry, ID is not changed here. So 32. So here ID would not change. There's something is odd here, but here ID would change 600. And so by the way, there's one important thing is none. None means X is pointing to an empty object. So there was no object, it's just pointing to empty object. Okay, so it's also a useful thing sometimes. Okay, if you want same array, then you should use, for star I illustrated, but you can also use for plus. So this means this is same as x equal to x plus 2. It's not same, but effective operation. If I do this, I create a new array x. If I do this, I'll modify the array x. Okay, this is not creating a new x, but this is creating a new x. But the elements, all of them get incremented by 2. This is subtraction by 5. This is division, integer division by 10. Okay, so the same array if I do this, but if I do this, I create a new array. So I think I will not detail here. I illustrated several examples which show the difference between Python and C. Okay, and we need to be careful. Just to so if I was doing C equal to A, if A was an array, then this will not create a new array in Python. No new array. But if I say C equal to A, then C will be a new array. So there was array A, and we'll get a new array C, which will be copy. Okay. So this is one thing which we learned. We also, if I do some operation on A, so A equal to 2 star array. So this creates a new array in Python, but not in C. So I think these are two things which I illustrated here. Okay, thank you.